Everyone. I am Apurva Karni, currently pursuing my master's in software engineering with a specialization in data science. Today, I'm excited to present on intelligent cross-organizational process mining. It is a cutting-edge field that's changing how businesses collaborate and optimize their processes. So, what exactly is process mining? Process mining actually bridges the gap between business processes and data science. It extracts insights from event logs to optimize workflows, enhancing operational efficiency and decision making across organizations. So, as you can see, there are three or four core components: discovery, conformance, enhancement, and workflow. So, so as you can see, the image has the workflow process mining, which like it starts with extracting event data from various sources, and then moves through stages of data filtering, selection, model building, optimization. So this cycle of analysis and improvement is the heart of this process mining. So as you can see, first we're doing the ETL process on the event data, and then the model building where a human will be required to select or get the best models whatever are there, and then perform diagnostics where there'll be a discussion with the team or with the businesses, and then after that the final stage will be the implementation, after which it will be deployed. So, what exactly are the latest advances in process mining according to the paper? So, the recent advancements include data centric process mining, which, as you can see, it addresses privacy concerns using techniques like federated learning. So, because data is taken from various sources, it is hard to keep track of uh, privacy. So, like, if there's a private data or something like that, it is hard to like mask it or something like that. So using federated learning we can achieve privacy concerns also. And then since the data is taken from different sources, there is also a chance of handling like having missing data. So even that is taken care by this data centric process mining. And then we have object centric process mining, which handles convergence and divergence issues in complex processes. And then we have customized metrics in AutoML. So like with the integration of AutoML, process mining can become a much better process because we can tailor computing services to specific users or silos or like organizations of such. So, and even the algorithm selection and hyperparameter tuning for optimal performance can also be automated. And the last one is efficient computing infrastructures. So in this so utilizing distributed computing, we can improve the reliability and scalability of these processes. And yeah, so it actually tailors the solutions to specific needs, while efficient computing infrastructure enables the processing of massive data sets. Moving on to the industrial applications. So as you can see, these are a few of the industrial applications of process mining for now. So the first one is manufacturing and logistics. So here process mining optimizes supply chains by analyzing event logs from various stages of production and distribution. And then as you can see, this dotted line would be the data flow and the solid line is the process flow. This is where process mining comes into picture. And then we have healthcare where it improves patient care coordination. So you can see this figure. It shows how data from hospital information systems like HIS is used to create process models, therefore enhancing efficiency and patient outcomes. You can see these three are the core components which are applied, and then this is the final model, which is very helpful. So the third one would be in the finance sector. So this where exactly process mining comes into picture, like it is crucial for compliance and risk management. So this figure, as you can see, it illustrates how data from document management uh, systems in insurance companies, it can be analyzed to improve back office processes. So the data is taken, and then all of the flow logs are done, and then the model is created based on the analysis, and then the final part would be uh, the improvement. Moving on to the other applications. So the first thing we have over here is procurement. So in this we see how process mining analyzes the entire procurement lifecycle from purchase requisition to payment, identifying bottlenecks and optimization opportunities. So yeah, and then the last one for this is blockchain. So in blockchain applications, process mining helps in analyzing smart contracts and transaction flows. So this in turn enables better monitoring and compliance checking in decentralized systems. And then after that, we have all of the resources and resources that are used in process mining. As you can see, various data sets and tools are available for process mining. So for data sets, they are mostly CSV files, they are transaction logs. They can be anything and anything because process mining can be done on a lot of different types of data. So and for tools, we have ProM, Disco, PM4, POI, all of these. And then we also have metrics and criteria on which this is checked upon. So for key like the key metrics that we look at are fitness, complexity, precision, generalization, and then the conformance checks. Those are done based on adaptability, generalizability, simplicity, and precision. Also, the performance, as we all know, it's based upon the time, the cost, and the quality of the process or the product. And then moving on to what exactly is intelligent cross organization process mining. So ICPM extends the traditional process mining by enabling collaboration across organizations. This is while also ensuring data privacy, which is the most important point. It integrates AI, federated learning, and customization to provide real time monitoring and predictive analysis. So, I would say like ICPM is crucial for optimizing complex interconnected business processes in modern supply chains and ecosystems. So, as you can see, these are a few of the key features. AI integration. So, what AI integration is like? Currently, like what they're working on is incorporating advanced machine learning and data analytics techniques to this particular process mining, which enables more sophisticated like pattern recognition, predictive capability, so that we can come up with better analysis. So, and then after that, we have privacy preservation using federated learning. So, using federated learning and other privacy preserving techniques, we can ensure the data is like it is private, like all of the like it allows the organizations to collaborate directly without you know being scared or being afraid of like sharing sensitive data which is not supposed to go out of the company. And it also ensures compliance with data protection regulations. And then finally, the second last thing I would say is customization. So what it does is like using ICPM, we can tailor analysis to specific organization needs and data types. So it also we can customize the metrics and the algorithms that are there. And then the last one is nothing but the real-time monitoring and predictive analysis. Because of using all of these AutoML or using machine learning and all of this customization, it is uh, said that the monitoring and the predictive analysis are done better. Moving on to the next slide. So there are a few challenges over here too. So the first one, so ICPM faces challenges in data privacy, handling diverse data forms, and ensuring explainability of uh, the process for adoption. So, but it also has like presents opportunities to through federated learning, using explainable AI for transparency, and also for customization, we can also use LLMs. So for the challenges, as you can see, data privacy, like we have to make sure that the sensitive data remains protected when collaborating with different organizations. And then since the data comes from like anywhere and everywhere, we have to make sure that the integration and the analysis of heterogeneous data is taken care of. And then ensuring explainability for adoption, like so making more complex ICPM models and results interpretable for like non-technical shareholders who want to know what's going on. And then data quality, since data comes from everywhere and everywhere, so we have to make sure the data is accurate across multiple organization sources. And then after that we have the opportunities. So federated learning is nothing but, like as discussed previously, it is for ensuring that the data privacy is taken care of and we are compliant. And then explainable AI for transparency. It So here we provide clear reasoning behind ICPM decisions and recommendations. And after that we have LLMs for domain specific insights. So what this does is it leverages large language models to extract nuanced industry specific knowledge from process data. Uh, yeah, this is all about ICPM and its introduction. So moving on to the proposed solution for ICPM, as you can see, what are done, like data privacy, security, handling of various diverse data modalities, and collaborative running. So these solutions, as you can see in the image, so the first thing is, we see 5 different data sources from where the data is coming, like energy, health, manufacture, business, government, and each of this sector maintains its own database of process data. And then the middle section is where this is the main part, I would say. Like the first step would be federated learning, where there's a secure collaboration between all of these data sources without any sensitive information or without any raw data. And then here we have distributed computing, which processes all of this data from multiple sources efficiently. And then also after that we have clustering. So clustering, it is something related to data mining, where we organize data from different scenes based on their characters. So so here we have 3 different task model pairs, I would say, like since we have a task and a model. So these are equipped with AutoML capabilities. So these handle the different aspects of process mining while also maintaining the data privacy. So the final stage of this process will be performance diagnosis using large language models, which is important because we want the stakeholders to know what is happening and to provide basically the insights to the stakeholders. So this whole architecture, it demonstrates how ICPM enables organizations to collaborate effectively with also preserving data privacy and handling different diverse data types through a sophisticated combination of federated learning, computing, and also uh, distributed computing, and also LLMs and AI, AutoML too. And then in the paper, they also mentioned about a few other future research directions which they wanted to like go through maybe in the future. So, according to them, like it should primarily focus on innovative algorithms, advanced privacy preserving methods, and ethical considerations, and like different data integration methods. There's also potential for like greater adoption through explainable AI for explaining to the stakeholders in a better way, and also domain specific customization of LLMs, which we already discussed in the previous slide. So these are a few of the few research directions which we can go. And I would like to conclude and give my personal opinion on this by saying ICPM is more than just a technical innovation. It is a vision of how data science can create a more interconnected world. So, as a data scientist student, I'm excited about its potential to reshape cross organization collaboration while maintaining ethical standards and data privacy, which is important again. So ICPM represents a step towards more efficient, interconnected world, while also maintaining a balance between innovation with security and privacy. So I would like to encourage everyone, whoever is watching this, to explore this field and challenge these kind of problems, to adopt these technologies and maybe move forward. So I would like to conclude by saying the fusion of cutting edge technologies like AI, federated learning, AutoML with real world applications that we saw previously in process mining, it can solve challenges that seem uh, very, unaccomplished or whatever, like a few years ago, which we couldn't do, but now we are able to do. So, yeah, I believe that we can like come together and make a better model on this, or maybe work a bit more and step towards more interconnected efficient world. And as discussed earlier, I this is a paper that so my presentation is on a paper that I've attached here, and I've also written a Medium article, and also I'll be uploading this to the SlideShare and attach the link in the bio. So yeah, thank you.